1% less than the acceleration due to gravity. When the distance is increased, naturally force has to decrease. So when they are separated by this distance r, when r is the distance between them, acceleration due to gravity on the surface of the earth. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. My discussion in today's session will figure out on the chapter Gravitation. We have already finished the concept class on this chapter. Today's session, we will focus and work out the numericals from this chapter. The first problem, a very simple problem, where the problem says we have to calculate the gravitational force between two mass of 15 kg each. The mass of the two bodies is 15 kg and they are separated by a distance of 2 meters, given the value of gravitational constant. So on analyzing the question, collecting the data, M1 equals 15 kg, M2 is again 15 kg, and the distance of separation is 2 meters. Provided this data, I have to calculate the force of attraction, gravitational force, for which I use Newton's law of gravitation, where I write F equals G M1 M2 by R square. So we get this expression from Newton's laws of gravitation. Substituting, the value of gravitational constant should be well known to you all. 6.67 into 10 power minus 11. M1 is 15 kgs. M2 is again 15 kgs divided by 2 square, the distance. And on simplification, this is 3.75 into 10 power minus 9 Newton. So this is the gravitational force between the two bodies. The next one, students. This is an important problem. So this is quite often asked in the exam. Find the height I have to find the height at which acceleration due to gravity is 1% less 1% less than its value on the surface of the earth. Given radius of the earth is 6,400 kilometers. Very interesting. I have to find the height where acceleration due to gravity is 1% less than its value on the surface of the earth. Now we know above the surface of the earth, so above the surface of the earth, G dash equals G 1 minus 2h divided by r. All these things we have studied in our concept class. Above the surface of the earth, G dash is G minus 2h by r. Now what is given? Very clearly he says G dash is 99 by 100 times G. So it is 1% less than the acceleration due to gravity on the surface of the earth. So G dash equals 99 by 100 times G. So substituting in this expression, 99 by 100 times G equals G 1 minus 2h by r. So this G and G gets cancelled. Or this 0.99 is 1 minus 2h by r. Or 2h by r now becomes 0.01. I will have to calculate h, which is 0.01 into r by 2. The value of the radius of the earth is given. So h is 6,400 into 0.01 by 2, where h is equal to 32 kilometer, or h equals 32 into 10 power 3 meters. So this will be the height above the surface of the earth, where acceleration due to gravity is 1% less. Next one, students. Yeah. Again, an important problem. This is a 5-mark problem, which is usually asked in the exam. The mass of a sphere is 2 times or twice the mass of another sphere. The mass of a sphere is twice the mass of another sphere. These spheres attract each other with a force of 2 into 10 power minus 4 Newton. So, what is happening here is, when they are separated by a certain distance, the two spheres, they attract each other with a force of 2 into 10 power minus 4 Newton. When they are moved 0.3 meter apart, the force reduces to 5 into 10 power minus 5 Newton. When the distance is increased, naturally force has to decrease. Find the mass of the spheres and initial separation between them. Now, according to the given problem, I say, let M1 be equal to M. So, mass of the other sphere is twice the mass of one of the spheres. So, M2 is given to be 2 times M. So, we know F equals G M1 M2 by R square. So when they are separated by this distance R, when R is the distance between them, force is 2 into 10 power minus 4 Newton. So this is 2 into 10 power minus 4. I keep G as it is. M into 2M by R square. I call this equation 1. Now what is happening to the distance? They are moved 0.3 meter apart. The distance between the two spheres is increased by 0.3 meter. That is, when R dash now is R plus 0.3 meter, the force has reduced to 5 into 10 power minus 5 Newton. So now it is 5 into 10 power minus 5. So 5 into 10 power minus 5 G into M into 2M R plus 0.3 whole square, and I call this equation 2. Now, I will first find the value of R, the separation between them. So we divide equation 1 divided by equation 2. So when we divide equation 1 by equation 2, 2 by 5 is r plus 0.3 divided by r whole square. Now taking square roots on both sides, on simplification, the value of r turns out to be 0.3 meters. So this simplification is your job. I've done favorable number of problems. Here I'm giving you the concepts, even the substitution. The final job is always yours. Now I want to find the mass of each sphere, for which I will substitute the value of r in equation 1. So we have 2 into 10 power minus 4. Now we will substitute for g, 6, 7 into 10 power minus 11 into m into 2m by 0.3 whole square. So on simplification, so this turns out to be nearly 367 kgs, which means again m1 has to be m and m2 has to be 2 times m. So just multiply this with 2, you get the second mass m2. Again, an interesting problem. Calculate the height at which acceleration due to gravity becomes 1/16th of its value on the surface of the earth. Exactly similar to the first problem, but I will slightly rearrange the expression. Here, again, above the surface, I will use the expression g dash is g divided by 1 plus h divided by r the whole square. This modified gives you the first expression we used. Given g dash is g by 16 now. 1 divided by 16 acceleration due to gravity on the surface of the earth, which means g dash is g by 16, g 1 plus h by r whole square. G and G gets cancelled, or we have 1 plus h by r whole square is 16. 1 plus h by r is equal to 4, or h by r is equal to 3. So h is 3 times r, 3 into 6,400 kilometers, which turns out to be 19,200 kilometers. See again, just how to simplify the expressions. It is very easy for us to solve the problems. In my next session, I come up with few more interesting problems from the chapter Gravitation. Until then, have a nice time. Thank you.